Okay, so for this video, I'll be going through your work energy power tutorial, question 1. Okay, so the question is as such. Figure 1 shows a simple pendulum which swings from A to B to C, A to B to C. Okay, the pendulum bob has a mass of 20 grams. Now, bearing in mind that everything in this chapter must be in SI unit, so maybe I change the mass, which is M, to SI unit of kg, so I need to divide by 1000, so I'll get 0.02 kg. Okay, because if I were to use it in the formula, I will need it to be in SI unit, and the SI unit for mass is in kg. So I also see that the height, it was raised above B. Okay, at A, it was raised above B with a height of 15 cm, so this is the height. So again, everything here must be in SI unit. For work energy power, I will divide by 100 to get 0.15 meters. Okay, so now the bob is released from position A. So at position A, it actually has energy in the gravitational potential store. Okay, and because it is released from position A, okay, I will say that it is not moving initially. Okay, so the energy in the kinetic store is 0. Why? Because it was initially at rest. It was released there, right? Initially, it was at rest. Okay, so then assuming that G equals to 10 Newton per kg, that's the gravitational field strength. Calculate the change in energy in the gravitational potential store when the bob swings from A to B. Okay, so at A, we take note that the energy in the gravitational potential store is actually the maximum. When it swings to B, okay, and B being the reference lowest position, I would say that the gravitational potential store, the energy in the gravitational potential store is 0. Okay, so they want us to calculate the change. So let us calculate the initial, the energy in the gravitational potential store at A. We use the formula mgh equals to 0.02, which is our M. G is 10, the H is 0.15, and that gives us a value of 0.030 joules. Okay, so this is the change in the energy in the gravitational potential store from a maximum of 0.03 to 0, right? So this is the change in energy. Now, ignoring the effects of air resistance, state the energy of the kinetic store of the bob at B. Okay, they want us to state. So it's a bit strange that they didn't want us to calculate. Why state? Because actually, if initially we had energy in the gravitational potential store, okay, and we have 0 energy in the kinetic store, so when it goes to B, B will actually have the greater speed. Correct? Because it was released at A. At B, it has the greater speed. So if it has a greater speed, then it will have the greatest energy in the kinetic store. Okay? Therefore, the energy in the kinetic store at B is actually equals to 0.030 joules. Okay? Then they want us to calculate the speed of the bob as it passes position B. So with this EK of 0.03, I can equate it to half mv square, right? So with this, I can calculate the V. Therefore, my V square is equal to, it is equals to square root 3. Therefore, my V is 1.73 meter per second. Okay? Now, when the bob swings up towards C, it reaches a maximum height that is lower than position A. Explain why the bob is unable to reach the same height as position A. Okay, so actually, in part C, we ask you all to, in part B, we say ignore effects of air. Okay, so just now I was saying that there was air resistance because in part B, right? In part B, we asked you to ignore the effects of air resistance. So now, because in reality there's air resistance, so as the pendulum bob swings from B to C, okay, it needs to do work. It needs to do work against air resistance, okay, because the air resistance is opposing it. So some of the energy will be transferred to the internal store of the surrounding by way of sound energy and thermal energy. Okay. Okay, so the observation is that air resistance acts on the bob as it swings from A towards C, right? So not just from B to C, but from A to B to C and back to B to A, there's always air resistance, right? Because it's in moving in air. So the explanation, due to work done against air resistance, right? I need to do work against air resistance. However, air resistance is a force, but I need energy to do work against this force. Okay, so some of the bob's total energy is transferred to the internal store of the surrounding. That means this energy is transferred out of the pendulum bob and into the internal store of the surrounding. So with some of this energy that is being transferred out to the surrounding, the remaining energy will be transferred to the gravitational potential store when at maximum height C. So because now I have lesser energy that is being transferred to the gravitational potential store, right? So it will be less than when it was at A, therefore the height of the bob at C will be lower than at A. Okay, you must know how to write things like this. This kind of question is very common.